Welcome to the latest video tutorial. In this tutorial, we're going to go over the two-phase method for simplex. For details about the simplex, please see the previous video. We are going to touch on it briefly though. So here I have an LP. I have a minimization problem. I see I have 3 variables and 2 constraints. One is inequality constraint and one is an equality constraint. So to start, for simplex, we want equality constraint. So like we've done before, we're going to do an augmented LP first. And so we're going to take the objective function as is and keep it like that. But now we're going to take this inequality constraint here and make it an equality. To do that, we add in an artificial variable or a slack variable, x4 here. And I'm going to change this to an equality constraint. So before, if this had evaluated to less than 9, this x4 value could be positive and it would make it equal to 9. This next constraint is already equality, and so we can just keep it as is. But now I need to have non-negativity for my original 3 variables, but also for my new slack variable x4. So this would be my augmented LP. And so when we plug step, we could plug this right into simplex, but we know for simplex we have to have a starting feasible solution. So in the past, where we had 2 inequality constraints, we would add an extra variable and then just set those 2 slack variables equal to this right-hand side. Here we only have 1 slack variable, so it's hard to see a starting solution where I have 2 non-zero variables. So to combat that, we do what I would call an artificial LP. And to do that, we're going to take this exactly as is, but then add in an extra variable here plus x5. Let's just have this line up like that. Just know I have x4 here and x5 even though they're in the same column. And keep it at equality. However, I know if x5 is positive, then a solution here is not feasible to this solution here. So this constraint says I have to exactly equal it. If x5 was ever positive, then it's not a feasible solution. So for my objective here, I'm going to change it. I'm just looking for my first phase. I'm just looking for a feasible solution. Therefore, I want to minimize x5. I'm going to take this as low as possible to 0. And I forgot here, I have to add in x5 also has to be greater or equal to 0. But I want to minimize x5. Take this as low as possible and then get a feasible solution. I don't care if it's the optimal solution to this objective function. I just want it to be feasible for this set of constraints. And so we solve this, get a feasible solution, and then worry about this objective function. So here I'm going to take this LP. I have everything I need to start in simplex. I have equality constraints, I have non-negative variables, and so I'm going to take this and plug it into the Excel document that Professor Sharkey has provided on LMS. So as I said with the simplex video, I've changed it slightly. It's pretty much the same. I've just added borders to make things easier of what you're looking at, and then this solution row, which we'll go over. It's just an easy way to see how you assign the solutions to these variables. So to start, I'm just going to signify that this row is for the objective function and these are for constraints. And then I'm going to look at here, I want to minimize x5. So essentially I'm setting z minus x5 equal to a value. So I'm going to take -1 there and 0 for the rest of these. Then I'm going to plug in my constraints. So I have 1, 18, -2, 1, 0. So 1, 18, -2, 1, 0. And the right hand side was 9. And then here, I'm going to take 1, 1, minus 3. x4 is not present, and then 1 for, so wait, 1, 1, minus 3. 1, 1, minus 3. x4 is not present, but x5 is, and then the right-hand side was 1. And so with this, I can see an easy, basic, feasible solution. Because x4 and x5 only appear in one constraint, I can set these x1, x2, and x3 equal to 0, because I have 2 constraints, meaning I need 3 non-basic and 2 basic variables. The number of basic variables equals the number of constraints that you have. So if I just set x4 equal to 9 and x5 equal to 1, I have a feasible starting solution for this LP. So looking at this though, if I had x4 and x5 as my basic variables, I know in a tableau for basic variables, they have to be linearly independent, meaning it's 1 in all zeros and then 1 in all zeros. That is not the case for this tableau. Therefore, I need to multiply stuff in order to make it a feasible, basic feasible solution for this tableau. So I look here, if this was a 0, I would be fine. That's the only thing I need to change is this x5 value here in the objective function row. So, I also forgot to put a 0 here for the objective function value. And so to do that, I'm going to forget the min ratio test. I'm not ready for that yet. I don't have it in the right format. All I'm doing is I'm saying if I took this row and added it to this row, I could have a 0. So I'm going to take this row 10 as my pivot row. 0, 1. So this is just answering yes or no, is this your pivot row? And this is my pivot row. And if I keep everything the same, and for this row, I'm going to multiply it 1 times the pivot row here, and then the rest I'm going to multiply 0. So what I did here is I'm just trying to zero out this value right here to get my basic feasible solution correct. I still have the same basic variables, x4, capital X4, and x5. So these are correct now. You can see I have 1. The solution is 9 because it's equal to this right-hand side, and then x5 is 1. It's equal to 1. So essentially, I've just formulated this LP. So I'm setting x4 equal to 9, x5 equal to 1, the rest of these equal to 0, and made it so it's in the correct form. That's the first thing that I need to do. Now, with my, I am minimizing, therefore I want to check, do I have the optimal solution? I'm in the right form, I can ask that question. And to answer that, I look at my reduced costs here. And so with my reduced costs, I'm in a minimization problem. So if I have positive reduced costs for any of these values, that means I am not optimal. So I have a positive reduced cost for x1 and x2. I'm going to just pick the lowest index, so here x1, to pivot into the basis. So what I'm saying here, I have to do the min ratio test. So for the min ratio test, it's just answering how far can I push x1 without violating the non-negativity constraint. I go into more detail in the simplex video with that. But essentially, you're just taking the right-hand side divided by the coefficient of the column that you're pivoting in. And for all of the rows here. So 1 divided by 1, 9 divided by 1. Here I take the minimum positive value, so 1. It's saying I can increase x1 to 1, and then x5 will be forced to 0. So essentially here I'm switching in x1 and moving out x5. So all I did, I kept x4 the same, and I'm switching x1 for x5. And now, because x1 is becoming my basic variable, I need to have it to be 1 in all zeros. So I'm picking here row 18 as my pivot row. And now I need to decide, what am I multiplying stuff by? So here I can just multiply -1. So I'm taking 1 plus -1 times 1 equal to 0. Here, again, I'm taking negative 1. 1 plus negative 1 times 1 equals 0. That should equal there. And then here, I'm just multiplying times 1. And these are not going through. 1 second. Maybe I have the wrong formula. There we go. It was just not going over correctly. So here, I fill in my coefficients. And so now I can see, okay, gut check. I'm minimizing, so look at my objective function value. Am I getting lower? I am. Do I have two basic variables? So here I say x4 is a basic variable. Yes, 1, all 0, and its solution equals to its right-hand side. x1 is a basic variable, 1, the rest 0, and its solution equals the right-hand side. Now I can ask myself, am I optimal for this solution? And I'm minimizing, therefore I'm looking for positive reduced costs. I see I do not have any positive reduced costs. Therefore, I am optimal for the original objective function. But really, what it's saying here is I know I have a feasible solution for the constraints. x5 is equal to 0. So really, I'm just focusing on x1 equal to 1 and x4 equal to 8. So if I look back here, x5 was this artificial variable that I wanted to drive down to 0 because I wanted it to be all the other variables to be feasible in this augmented LP. I wanted x5 to be 0. And so now I know that x1 equal to 1 and x4 equal to 8 is a feasible solution for this set of constraints. So therefore, I can just focus back onto this objective function. I know I'm optimal for this, switch to this objective function with the same constraints. So here I have 7, negative 9, 4, but I flip those. So I'm going to now ignore x5. I don't have to worry about it because it's now not in my new LP. So I had negative 7, because it was 7, I take the negative of it, 9, negative 4, and then it was 0. And so here now, I'm saying my basic feasible solution is x4 and x1. I need to say, with this new objective function, am I in the correct form? So for a basic feasible solution, I have to have 1 and all zeros, and then 1 and all zeros. So x4 is fine, but x1 is not because I have a negative 7 here. So now I just need to pivot on this row 25 to zero out this value, negative 7. So I'm going to pivot on 25. I'm going to set that equal to my pivot row.
4 o'clock.
Oh, it's 4 o'clock. Here I'm just multiplying times 7. I don't have to worry about the min ratio test because right now I'm just trying to get it into the correct form. So here if I multiply negative 7 plus 7 times this value, I'm going to zero out. I want to keep this still 0. I want to keep u1 and get that solution. Here my basic variables are exactly the same. And now I want to know, do I have a basic, is this in the correct form? So I scroll down a little bit. So I'm looking. I have x4, 1 and all zeros. x1, 1 and all zeros. Their solution values equals their right-hand side of the corresponding constraint. Yes, I'm in the correct form. Now I can ask, am I optimal? I look at my reduced costs. I realize I'm in a minimization problem. I'm looking for positive reduced costs. This positive 16 means I can increase x2 and get a lower objective function value. So I'm going to do my min ratio test to decide how far can I increase x2. So I'm taking the right-hand side divided by its coefficient for both of these values. And here I see I get 0.47 and 1. I realize 0.47 is a smaller number, therefore I'm going to take x2 into the basis and x4 out. So here I have x2 and x1 stays the same. I'm realizing 31 here is my pivot row. I'm going to answer 0, 1, 0 for pivot row because this is my pivot row. And now I need to do coefficients. I want to get this value to 1 and the rest 0. So to get this to 0, I'm essentially taking the negative of this divided by 17, the coefficient in the pivot row. So it ends up being this weird value. This is just 1 divided by its value. And here is the negative of this divided by the value in the pivot row. And so you can play with these values to try to get it. The point is you put values in here so you get your entering variable to be 1 and the rest zeros. And so now I realize, okay, I'm in a minimization problem. My previous objective function value was 7. I've decreased. That's good. I'm making progress. Now I have x1 and x2 as my basic variables. Do they make sense? Yes. x1 here, all zeros, and its solution equals its right-hand side. x2 is the same, 1, the rest zeros, its solution equals its right-hand side. Now I can look at my reduced costs. Am I optimal? I'm in a minimization problem. I look for positive reduced costs. I see that I have 0 positive reduced costs. Therefore, I am optimal. So my optimal solution is x1 equal to 0.53 and x2 equal to 0.47 with the rest equal to 0. So that is a way to have it where you start and solve it with simplex the entire way through. Let's say you plugged it into Solver. You plugged this here, this artificial LP into Solver and says minimize this, and you got a solution. And let's say your solution was that x1 equal to 1 and x4 equal to 8. So the same solution we saw right here when we were done was x4 equal to 8 and x1 equal to 1. How do you then start the next one? So I've taken a tableau here where I want x4 and x1 to be my basic variables. So I've put them in here. I still have 1, 0, 0. And this tableau here is exactly equal to the constraints of your augmented LP. So you can see negative 7, 9, 4, negative 7, 9, 4. And these constraints are exactly what the constraints are in that augmented LP. And so I know that I want x1 and x4 to be my basic variables. So with that, I realize I need to do different pivots or Gaussian elimination in order to get that the case. So for x4 to be a basic variable, I look at its column, 1 and all zeros. I'm cool there. x4 is good. x1, that's not the case. Here, x1 is that. I have 1, I have negative 7, 1. So it's not correct. So I need to zero out these values to make it in the correct tableau, and then I can continue with Cplex. So this is just 2 ways to get a starting feasible solution. And so here I know I need to do pivots on x1, so that's going to be my pivot row, 10. I'm going to answer 0, 0, 1. I don't need to worry about the min ratio test. I'm just trying to get it into the correct form. So here I'm going to multiply times 7. I want to get rid of this 7. I want it to be a 0. I want to get rid of this 1. I'm going to multiply times negative 1. And I want to keep this 1, so I'm going to multiply it by itself. So here we see we get a new tableau. Again, we're having x4 and x1 as my basic variables. Gut check it. x4, 1 and all zeros. Its solution equals its right-hand side. Here, x1, 1 and all zeros, and its solution equals its right-hand side. So we're good with that. And you'll notice that this tableau here is exactly equal to this tableau here. Forget the min ratio test and others. So once you get there, you just continue with Cplex with this objective function. You would pivot on x2 like we did over here and solve it according to that. So what we did in this tutorial was we took an LP, made it an augmented LP, and then added artificial variables. We then took that LP to get a feasible solution, feasible starting solution, and then optimized based on our original objective function here. So I hope this was less blurry than the previous Excel documents, Excel tutorials. Feedback is always welcome, and request videos on the website. Thanks. Bye.